According to the National Electrical Code, you cannot use aluminum wire as a grounding conductor, even if the wire is insulated. The code mandates that the grounding conductor must be either bare copper or an insulated or covered copper conductor with an outer finish that is either green or green with a yellow stripe. This requirement is clearly stated within the National Electrical Code, and it is crucial to adhere to it for safety reasons. Grounding conductors play a vital role in electrical systems, providing a path for fault current to return to the source, which in turn helps to trip a circuit breaker or fuse, thereby preventing electrical shock and fire hazards. The use of aluminum for grounding conductors is prohibited due to its properties and potential for corrosion and oxidation, which can compromise the effectiveness of the grounding system over time. Copper, on the other hand, is a highly conductive and corrosion-resistant material that is ideal for grounding applications. When installing a sub-panel for a pool, it is particularly important to follow all applicable electrical codes and regulations to ensure the safety of swimmers and other individuals who may be in contact with the pool or its electrical equipment. The National Electrical Code has specific requirements for pool electrical systems, including bonding and grounding requirements to minimize the risk of electrical shock hazards. Firstly, ensure that all metallic parts of the pool, including the pool structure, metal fittings, and any metal equipment associated with the pool, are properly bonded together. This bonding helps to create an equipotential plane, which reduces the voltage difference between different metallic objects in the pool area. Secondly, the pool sub-panel must be properly grounded to the grounding electrode system of the building or structure. This grounding provides a low impedance path for fault current to return to the source. Thirdly, all electrical equipment associated with the pool, such as pumps, filters, and heaters, must be properly grounded in accordance with the National Electrical Code. This grounding helps to prevent electrical shock hazards in the event of a fault in the equipment. Fourthly, ground fault circuit interrupters, or GFCIs, are required for many circuits in pool areas, including outlets, lighting, and equipment circuits. GFCIs are designed to detect ground faults and quickly interrupt the circuit, thereby preventing electrical shock hazards. Fifthly, all wiring and electrical equipment in the pool area must be suitable for wet locations. This includes using waterproof boxes, fittings, and wiring methods to protect against moisture and corrosion. Sixthly, it is essential to follow all manufacturers' instructions and recommendations when installing electrical equipment associated with the pool. This includes proper wiring connections, grounding, and protection against overcurrents. Seventhly, it is recommended to have a qualified electrician perform all electrical work associated with the pool. A qualified electrician has the knowledge, skills, and experience to ensure that the electrical system is installed safely and in accordance with all applicable codes and regulations. When running wires in a conduit to the pool sub-panel, it is important to ensure that the conduit is properly sized and installed. The conduit should be large enough to accommodate the wires without overcrowding, and it should be installed in accordance with the National Electrical Code. The National Electrical Code specifies the maximum number of conductors that can be installed in a conduit of a given size. This information can be found in Chapter 9, Table 1 of the National Electrical Code. When determining the number of conductors that can be installed in a conduit, it is important to consider the size of the conductors, the type of insulation, and the ambient temperature. The National Electrical Code also specifies the ampacity of conductors, which is the maximum current that a conductor can carry safely without exceeding its temperature rating. The ampacity of a conductor depends on its size, type of insulation, and the ambient temperature. This information can be found in Table 310.16 of the National Electrical Code. It is important to select conductors with an ampacity that is sufficient to carry the load that they will be serving. When running wires in a conduit, it is important to avoid damaging the insulation on the wires. Damage to the insulation can create a path for electrical leakage, which can lead to electrical shock hazards. It is also important to properly terminate the wires at both ends. This includes using appropriate connectors and making sure that the connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to electrical fires. In addition to following the National Electrical Code, It is also important to follow all local codes and regulations. Local codes may have additional requirements for pool electrical systems. It is always best to check with the local building department to ensure that you are in compliance with all applicable codes and regulations. Remember that working with electricity can be dangerous, and it is always best to hire a qualified electrician to perform electrical work. A qualified electrician has the knowledge, skills, and experience to ensure that the electrical system is installed safely and in accordance with all applicable codes and regulations. Additionally, remember that ground wires should always be green or bare copper. The use of aluminum is prohibited. He mentioned running 4 wires in a pipe, 2 hots, 1 neutral, and 1 ground. This configuration is typical for a single-phase, 3-wire system, which is commonly used in residential applications. The 2 hot wires carry the current to the load, the neutral wire provides a return path for the current, and the ground wire provides a path for fault current to return to the source. It is important to ensure that the neutral and ground wires are properly sized and connected. The neutral wire should be sized to carry the maximum unbalanced load that it will be serving. The ground wire should be sized in accordance with Table 250.122 of the National Electrical Code. The size of the ground wire depends on the size of the overcurrent protective device protecting the circuit. It is also important to ensure that the neutral and ground wires are properly bonded together at the service entrance. This bonding provides a low impedance path for fault current to return to the source. In addition to the above requirements, it is also important to follow all other applicable requirements of the National Electrical Code. The National Electrical Code is a comprehensive set of standards for electrical installations, and it is important to be familiar with its requirements. The National Electrical Code is updated every 3 years, so it is important to make sure that you are using the latest version of the code. The National Electrical Code is available for purchase from the National Fire Protection Association. You can also access the National Electrical Code online through various subscription services. When working with electricity, it is always important to take precautions to protect yourself from electrical shock. This includes wearing rubber gloves and shoes, and using insulated tools. It is also important to turn off the power to the circuit before working on it. You can turn off the power to the circuit by flipping the circuit breaker or removing the fuse. Before working on the circuit, it is important to test it to make sure that it is energized. You can test a circuit using a voltage tester. A voltage tester will indicate whether or not there is voltage present in the circuit. If the voltage tester indicates that there is voltage present, do not work on the circuit. Wait until the circuit is energized before working on it. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to ensure that the electrical work is done safely and in accordance with all applicable codes and regulations. Remember, safety should always be your top priority when working with electricity. If you are ever unsure about something, it is always best to err on the side of caution and seek professional help. Grounding is a critical aspect of electrical safety, and it is important to understand the requirements of the National Electrical Code. The use of aluminum wire for grounding conductors is prohibited, and it is essential to use copper conductors instead. By following the National Electrical Code and taking appropriate safety precautions, you can help to ensure the safety of yourself and others when working with electricity. Finally, always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. Improper wiring can create dangerous situations, so ensure adherence to all regulations.